Hello, I'm audible. Hello. Yeah, let's wait for 5 minutes. Second. Yeah, I think we can start the session. So, welcome to all to this live question answering discussion session. So, this is an week 7. We are discussing the topics covered in the week 7, which is an information diffusion or behavior diffusion we have seen. Uh, right. So in that we have seen how the behavior is cascading in the network, and we have seen multiple techniques, how the behavior is influenced by the users based on the payoffs and based on the key nodes or key users from the network. Right? And also we have seen the what is the community impact on the cascade actually, right? There is a two community, and suppose the one community is infected, and then what is the possibility to infect the another community, right? There is an that cases we have seen in this week. Also we have seen the what is the impact of the clustering density on the cascading. So is there any strong density of cluster, is there is a strong uh, cluster density is there? It means there is a cluster in present in the network, and that cluster is an very highly connected to each other, and in that the cascade, the new information from the outside of that cluster passing to the or circulating in that particular cluster is difficult, right? So based on that that condition we have seen, right, clustering the density is greater than 1 minus q is, and that threshold we are putting into that, right? Yeah, let's jump onto the questions. The questions we are covering in this live question and interaction discussion, which is and the last year questions of this respective week actually. So this will help you to solve this year assignment questions. Will much of the questions are related, and also you will also understand or clear some silly doubts. We can discuss any you have any doubts uh, while learning this concept. Okay. Yeah. So the first question is that consider the modeling of information cascade in a graph G, where everyone start with B, and there is a small set S of early adopters of A. Given this condition, given this network, so there is a two statements has been given. The first statement, which is an nodes in S keep using A no matter what payoffs tell them to do. And second statement is that nodes outside of the S, which is an, we can say this is an seed nodes. Okay. The nodes outside the S keep using B no matter what payoffs tell them to do. Let's visualize this problem. How, what this problem is saying. Right? Suppose we have a network, and in this network, where is, these are the seed nodes, right? And the question is saying that we have this, all network is there, and this uh, red colored node, those nodes has adopted the a a information. This is an e information they have done. And other than these two nodes in the network, other nodes has adopted as an b, where b information, right? Right. So here this set S, which includes these nodes, we can say we can, yeah, giving some name here, that is an 1, 2, 3, 4, 5, 6, 7. These are the node numbers, we can say that. Okay. And in the initial S dictionary, which has adopted the A information, sorry, information, which is an one node and node number 5. So, so considering this is the question is stated there. So considering this condition, the first statement says that nodes in S keep using A no matter what payoffs tell them. So this early adopted A behavior or A information. It's, they are not changing. They are initially adopted this information, right? So so what do you think? Which option would be correct in this scenario? Yes. So the the first statement is saying that there is a no modification, or not, the 1 and 5 nodes are, they are not changing their state actually A to B. They are keep in state A actually, which has A information. Okay. And second statement is saying that outside of the S, which means the other nodes from the network, which has adopted the B information, no matter what payoffs tell them to do, choose the correct. So let's take one example. The first statement, we can say that it is isn't correct, because the two nodes, it hasn't adopted the information early state. They are not adopted the information by influencing someone. They have the initial users, we can see that. Okay. And by using these two nodes, is there any changes will be done in the other network, right? There will be changes will be done, right, by using the cascade diffusion, right? Cascades means by influence, by using these two nodes, how many nodes of their network will be adopted the b information by the concept of the cascade diffusion, right? So there is a two states are there. There is an suppose this node has an b information currently, when he will adopt the a information, when he will get higher payoff from the a information, means his neighboring node which has an higher payoff, they are providing to that particular node number 7, then he will adopted that information b, right? So you can see the no matter what payoffs will be get, so the higher payoff will get, in that case the other nodes will get adapted to the information a as well, right? So this statement is not correct. They are saying how whatever the payoffs they will get, they are not adapting the new information, right? So it's not true, right? In the diffusion process, nodes get adapted to the new information when that particular node gets higher payoff, higher benefit by adopting that information. As we have seen that example which has covered in the lecture, which is there is an one company. If you have a one means shoe company is there, and that shoe company has given he has given you offer uh, that if you have influence to other five users, then we will provide you as an free shoes, right? So you will get a payoff, that is payoff is in terms of the shoes, no matter how what is the quality of that particular shoes, but you will get a free shoes, right? By using that free shoes, you will adopt that information, right? Adopted that information, that is a new shoes, you will adapt it, and you will also influence to your trying to influence your friends, neighboring friends as well, right? So here the correct option is that the statement one is correct, but statement two is not correct, because of they are saying no matter how much payoffs will get, then a new information will not adapt it, right? But it's not true, right? In the diffusion process, you will get higher payoffs. In that case, you will adopt the new information, right? Comparative to other information, right? So here option is correct is that S1 is true, but S2 is false. That is, and second option is correct. Okay. I hope there is no doubts here. If you have any doubts, please let. Yeah, two. Yeah. So let's move to the another question. Consider a group of 10 bachelors. Right? There are 10 bachelor students are there, which is an, like we can say as an BTech student or BE student or BSc student. Those are the bachelor students. And from out of 10 bachelor student, five lives on the first floor of the apartment, and other five lives on the second floor of the apartment. So there is an one building, right? One apartment. In that apartment, ground floor, second floor, there are five bachelors are living, and in the first floor, which is and five another five bachelors are living, right? So considering this scenario, suppose that each bachelor in this group has an two friends in their own floor, right? There is an each bachelor students has an two uh, neighbors, two friends, which is in the same floor, and other on their friend, and one friend on the other floor. So here is the condition is that one is connected with the similar with this on the same floor friends, and another friendship has been done to the another floor. So there isn't two sections are there here, so two clusters are there. So here we can say in this cluster there is an five, uh, one, two, three, four. Let's see. five users are there, and here is also one, two, three, four, five users are. They are saying that two connections in between the cluster means same floor users, and the one connection will be on the other side of the community, right? Community or cluster, we can say that. Okay. So here we can say that floor one student as considered as a one community, and floor two, second floor, we can those living students in the second floor we consider as a second community. Okay. So here this is a second one first floor, and this is a second floor community, right? So there is two connections has been done, and one is from another, right? Two connection has been done and one connection from the another. Two connections has been done one another, like likewise the network is constructed here. You can see here one is here, another is maybe here, likewise another here, two, another here, likewise two here and one another, two here, one another, two here, one. So you can see the network. There is a much means there is a lot of edges in between the community as there are there. So it's not like that. Like there is a no weak ties are there, right? So in the weak ties, that is, and we are considering the two communities are there in segregated way, right? And the two communities connected by one only single age, right? And that single age represented as an weak tie or weak age, right? So considering that only one part of the community is influenced by the one single information, right? It's not, it's very less probability or less um, possibility to get this information, means one community one information will be passed to the another community, because there is only one age is there. But you can see here in this scenario there is two community, we have assumed that, and in that two communities there are lot of ages in between the communities, right? So considering this fact, this action will eventually adopted by. Okay. So so up to now we have seen this condition actually, right? Considering two friends and two. Now considering this fact, now a new restaurant opens, that is a new information comes. Okay. So which node has adopted that information, we doesn't know. Let's see which node has an adopted those information. So now a new restaurant opens, that is a new information, and five persons all living on the first floor, means this first floor. Okay. Each begin eating there on the first day, right? On the first day they have adopted this new information, that is a new information, as a new restaurant has opened. The second floor, they doesn't know about this information. Lata, you want to say something? Hmm. Yeah. So here, considering this fact, what could be the actions will be considered eventually, means after some times, what will be the condition of the network? So the condition will be the both of the community, both of the first floor of the persons and the second floor of the person has adopted this new information, or only the first floor students or first floor bachelor students has adopted this new information, right? There are multiple cases will be possible here, like already maybe this condition has been, or this scenario we have already discussed in the prior lectures. Let's say I will draw in a color way so you can understand better. Okay. So the firstly adopted, these are the users, these are adopted this new information, which is, and they are starting eating in the new restaurant, right? So nobody in the apartment, this action will eventually be adopted by nobody in the only the bachelors in the first floor, only the bachelors in the second floor, right? Only the first day they have uh, eat in that new restaurant, actually the first floor students. So right, the first, and then there is an another set of users. Those are from the first floor, and there is an multiple edges passing from this node, right? And in between there is also edges. These are only two edges, we can say that. Okay. So this might be influence, this users can influence to these users as well, and these users maybe get influenced to these users as well. And there is might be a real world scenario, might be at first day they have eat there, and but after that they have not liked that particular food, maybe. That is one scenario, right? So in this scenario, there is a no possibility. We can't definitely say that this only the first floor community, first floor bachelor students will adopt this information. It's not directly we can, or definitely we can say that. So here, the considering this all those factors, we cannot say something. Maybe the both of the community has been adopted that the new information, or only one community has adopted that information, or other than that no one has adopted that new information, because at the first day they have eat there, but after some time they are not eating there. They are not like to eat there, right? They have not no, they are not the food is not good that much. Maybe that is the one reason, right? So if the question has stated that if they have liked there, or they are usually going to that particular restaurant, so what is the possibility to get another community get influenced by the this first floor community, right? In that case we can say something. But here the question is given that only they have given to the goes to that particular new restaurant on the first day. Okay. And considering this scenario, what will be the happen? What will be get the network condition? Right? So in that case, the option 4 is correct. We can't say something. Right? Yeah. Okay, let's jump to the question 3. I hope there is no doubt in this question. If you have any doubts, please let me know. Okay. Question 3. If the payoff for working on your assignment, which is in point 3, and participating, there is another event, participating in a hackathon is point 5. So 5 of your friends are participating in the hackathon, and 6 of your friends are working on the assignment. What will you opt for? Means what you will be choose? Uh, Working on assignment or participating into the hackathon? Yes, anyone? This is very simple question actually. The first part of the lectures, this has covered actually. So there is an, for each information you will get some payoffs, right? And based on your how many neighbors has adopted or of that particular event, based on that you will get a payoff, and based on that you will choose which event you want to do. So what do you think, which option is correct, or how you can approach this question? Anyone? Is there any wrong option or wrong answer is there? There is no issue. We have, this is an interactive session. We will discuss on that, and we'll resolve the issue. Okay. Is anyone? Okay. So let's visualize this problem. So here, uh, the question is states that the 5 friends are participating in the hackathon. So let's assume that we have a V node, that is an, let's take a V as in, for V node we need to choose which decision he can take, right? So some of his friend, which are 5 friends, we can see here, 1 2 3 and 5. These are the 5 friends are there. friends are there. They have opt for the participating hackathon. They are going for the hackathon. There goes for hackathon. And six of his friend are working on the assignment. One, two, three, four, five, six. Right. Yeah, assignment. So, what is the payoff you will get for each event? So, they are stating that point three you will get. Second, you will get a point three payoff for the assignment if you choose to the get assignment, and you will get a payoff for point five for the hackathon. So this payoff you will get for one friend. If one friend is going to the participating in the hackathon, you will get a point five payoff. If only one of your friend is going to the going to working on assignment, then you will get a point three payoff. There are five, or there are suppose three of your neighbors or your friends are going to the participating in hackathon, then you will get a 3 into point 0.5 payoff likewise. Okay, so here the five neighbors are there, five friends, and here six friends are there. So considering this fact, so suppose we this node has choose to participate in hackathon, then how much uh, payoff he will get? So that is and the five. So 5 into point 0.5, right? So we get as an sorry 2.5 payoff, right? And suppose you have choose to you have choose to do work on assignment. So in that case, you will get a payoff which is and 6 into point 3, right? So in that case, how much you will get? Right, 1.8 maybe something, right? So which value is greater here? How much, which how from which event you will get higher payoff? So you can see for the hackathon we are getting as in 2.5, and from the assignment you will get as in zero point 0.1. So you definitely choosing as in participating in hackathon, right, by using this condition. So here the correct option is in participating in hackathon. You will participate on hackathon by based on your neighboring friends, right? Neighboring means neighboring nodes, those we are calling as in friends. Those are the friend of that particular user v. Okay. Yeah. Yeah. So this is a very simple question, right, that we have covered in in the last lecture. You have learned in this week lecture. So let's move to the another question, which states that in the context of the cascade adoption of behavior or product X, okay, and within a network, which statement is not possible? Considering a chain reaction of switches from Y to X. Right. So the question is states that let's try to visualize the info means question actually, how the information means how the question is stating that. Then you will get a clear idea what question is saying that. Right. So let's consider a network. This we have taken a random network. Okay. And in this network they are saying that there is an adoption of the context of adoption of the new behavior or product. Let's consider as a product. Okay, there is a new product is launched in the current scenario. Let's try. And all of this, in the network, all of the nodes, all of the users is already adopted another information which is an y. Why I have written the why? Because it's not stated directly in the question, but you can see here in the last statement, consider a chain reaction of switches from y to x. Means there is an already adopted y information, and what is the cascade in, what is the possibility to adopt new information x, right? So considering this scenario, what could not be possible? There are there are four statements are there which could not be true, or which could not be possible in this scenario, in this cascade diffusion scenario. So the first statement states that eventually all nodes adopt x over time. That might be possible. Okay, means all ads get as an, if everyone has get a higher payoff by adopting this new information, then they will get they will choose that particular new information, new product x, right? The second option states that the cascade initiates, but cascade initiates but halt before all the nodes transaction to x. That might be possible because there is a no changes over the period of, over the time, means there is a no change in the network. Means suppose there is a 10 nodes in the network, and 7 of the nodes has adopted the new information which is an x, and rest of the 3 nodes has adopted the other information which is an y. So after the iteration there is a no changes in the network. In that case there might be halt of this particular node transactions. So in the third option it states that at a point every node reverts to y. So they are saying that they are stating that y they have adopted already y, and it is saying that every node reverts to, suppose it is x, x has suppose any node has adopted the new information x, right? When you will adopt the a new information, when that particular node gets as a higher payout, right? If so, there is a possibility to revert back to the y, and every nodes too, means they are saying that suppose it means all of the network in the all the network, means all of the node from the network has adapted x information, and they have reverted back to the y information. It's not possible, right? They have adopted, if they have adopted all if all of the nodes has adopted the new information, there is no possibility to adapt the previously information, because there is no such node which has an previous information, right? So it is saying that at a point every nodes, it says that every node reverts to y. It means that the network has adopted, all of the nodes from the network has already adopted the y information, x information, and they are stating that it gets at a certain point of time that all of the nodes gets reverts to the y information. It's not possible, right? So this is one correct option which should not be possible in this scenario. The fourth option, only the initial seed nodes transition to the X. This we can't say. This might be true. Okay, only initial seeds means initial nodes. The suppose from the 10 nodes, only initial 2 nodes has adopted the transaction. There might be not possible means to other nodes or remaining nodes get adopted the X information, because they might not get that much higher payoff by adopting this X information, right? This might be case in this this could be possible, right? So these three of the options are possible, but the third option is not true. It's not possible in this network. Yeah. Is there any doubt? Okay. Let's move to the another question. This the density of the cluster. I think we have seen this question in the previous interactive session. So what is the density of the cluster? Anyone? So the already answer has given in the options. You have to choose only correct answer. What do you think? Which option is correct? What is an density of a cluster? Yeah, density means what means. I think in the lecture also this has covered. Means let's take as in one density scenario in the network. Right. So, considering this network, there is an one cluster we are considering here. This is an cluster. So we want to say that these four nodes, how much closely, how much tightly those nodes has connected to each other, right? So we are how we are quantifying the density, how much they are closely connected, how much they are tightly connected each other in a cluster. So considering this cluster, so how we are quantifying that? There are options are there. Nodes friends present in the inside the right. So their first option is saying that the first option is correct actually directly because there is no logic to see the other options actually. So here the fraction of nodes friends present inside the clusters. Suppose you have 10 friends. From out of 10 friends, how much friends are in the same cluster? Right. So if higher the number of your friends in the same cluster, then that means that is an tightly that much closely or that much tightly you are connected to each other. So then density of that particular cluster is very high. So each suppose here we can say the four friends are there, and four friends has an suppose there has an five. The total friends has an each of the four friends has an five friends are there. Okay, so you are getting na means there is an four nodes are there. For each node there is an five neighboring nodes are there, and out of the five, the four neighboring nodes are in the clusters for each of the node, right? For the node one, node two, node three, there are out of five, the four nodes are connected in same cluster. Okay, so in this case, the density of the cluster should be higher, right? So there is let's take another example. That is an suppose the node is there, and in that particular node there is an five neighbors are there, and from out of five neighbors, only one neighbor, one friend has connected in the cluster. For this scenario, we should be let's apply for the all of the neighbors that in that all of the nodes from the cluster. Then the clustering density of that particular cluster it's less, right? So by doing so, we are finding the density of the cluster, which is a fraction of nodes of friends present inside the cluster. Fraction of nodes friends present outside the cluster. It's not stating the particular answer actually. Average number of friends inside the cluster. It's not like that. Maximum number of friends inside the cluster. So, so now we have understand what is and how we can calculate as an density of the cluster. So considering that, can you please calculate the clustering density of the cluster for each of the cluster? Each of the cluster. There are four clusters are there. Three clusters are there which has an four nodes. Right. So suppose if you are calculating the cluster density of this cluster one, that cluster density should be what is the minimum cluster density for each node. And suppose it is getting an 2 2 2 and if that node has an 1, then clustering density of this particular cluster which is an 1 minimum we have to consider it. Likewise for each of the cluster. So considering this fact, what could be the clustering density for each of the cluster here? So here the 2 2 1, which is an intuitively taken the values, you have to calculate it the density, the clustering density. Yes, anyone? Yeah, option two. Yeah, Manish. So for A, B, C, and D, what is an uh, clustering density value for that particular node? For A, B, C, D, so it will be equal to means add to all. So clustering coefficient. Let's calculate it. How it is um, getting as an option two, 2/3. Or we don't know what is an correct option. Let's dig into it. Okay. So for the A node has an two neighbors, and out of two neighbors, you can see here, out of two neighbors, two of neighbors has an inside in the cluster. So it is an two divided by two, which get as an one. For B, you can see the three of neighbors as inside of the cluster. Three divided by three, it gives an one. C for three divided by three is equal to one. And you can see here for the D, the different scenario here. Out of three neighbors, only two of the neighbors has inside the cluster, which is n2 divided by 3. Right. So I already said that the reason we had to consider as a minimum node which has an mi- we need to consider the clustering density which has an which gives the node has a minimum the score which is n 2 divided by 3. For this graph, which is n 3 divided by 3 equal to 1, 3 divided by 3 is equal to 1. Here, 2 divided by 3, 2 divided by 3. That's it. So 2 divided by 3 are there. That's right. Here is also same. 1, 1, 1, 2 divided by 3. 2 divided by 3. So the option 2 is correct here. Okay. Okay, let's see the second next question. Consider a network where all of its nodes have adopted an idea A with a threshold Q for nodes in the remaining network to adopt A. Which of the following efforts can be a valid attempt to create a complete cascade of a new idea B in such a network? Select all that is applicable. So take a time, understand this question, okay, and try to think on this which option will be correct or what could be the possible ways we can adapt to the new information which is an B. Yes, anyone? Which options or which ways we can choose to cascade the information, new information in the network? Which ways we can, which methods we are considering um, to cascade the new information in the network, that in the network has already all the node has already adopted the a information. The node has an a information already has there, but how the nodes can be changed their information or their thinking to adopt the new idea b. So we have considered which is an to cascade diffusion. So when the node will gets or consider the new information, as already said in the first or second question, that if the node or if the user gets an higher payoff from that particular new information compared to the his present information, he has now in current scenario, in the present scenario, the node has the a information, and there is a new information coming it out, that is an B information. When he will choose the B information, if that particular node get higher payoff by adopting this information compared to this A information. Okay. Likewise. So let's consider that shoes information. So suppose the that particular user A, which has already using a shoes, which is, and let's take as an Bata company shoes. Okay, and there is a new company has launched, right? There is a new company, let's take as an Bakaboki. There is a one company has launched actually in the shoe market. So that there's offering, suppose you are buying one shoes which is around 1000, and you will get a new another new shoes, right? And in Bata you will get all the shoes greater than the 1000. Right. Only one shoes they are not offering, because this is a very traditional company, or this old company, and this is new shoes, new company. They are offered for the promoting their his company. They are offering one shoes, uh, one another shoes, if you are buying greater than 1000 shoes, right? So you are getting higher payoff, higher benefit to adopting that particular new company's product, right? So you will get, you are not choosing the Bata here, then you will choose the Bakaboki. That is one another the company names is very sting, but it's fine. That particular user will adopt that particular product which is in Bakabuki, and then he will also influence to the particular his neighboring. So you can adopt this information, because you can take this product, you will get another shoes, right? Likewise. So this is the same thing we are applying here. If you are getting higher payoff, then you are adopting the new information. So here you can see the increase the product price. Definitely you are not choosing that. If that particular Bakaboke shoes has an 6000 the price of that particular product, then you are not choosing that particular product, because you are getting the one in 1000, you are getting the Bata shoes, right? That is an A information, and B information is an backup issues here. Okay. So if their price is increased, you definitely not adopt that information. We need to choose here valid attempt to create a complete cascade of new info. Complete cascade means what? All of the network. Let's take as an 10 nodes in the network. They are connected each other by following, that connection represents and following to each other. So complete cascade means all of the nodes from the network has adapted the new information. There is no as such node present in the network which has an A information. Right? That is a complete cascade. So for finding, or for achieving the complete cascade network, what could be the actions you can take? That is a particularly definitely should not be product increase the product size. Another is you increase the product payoff. That is payoff means benefit. Increase the benefit. So it might be one possible. Another option, the no cluster with a density less than 1 minus q. Cluster density is not means, suppose there is a net density, the network is there, and that cluster density is higher than the threshold, right? No cluster, higher than the threshold, then there is a no information will be adopted in this cluster, right? There is a no. So considering this factor, which the complete cascade uh, will not get achieved, right? No cluster with density is less than means, there is no less than density values of the threshold. Another option which is, and find out the key people in the network to inject the idea. Right? The key people, we have this three possibility already seen in the lectures, which is, and how much means which actions, which methods you can adopt uh, to cascade the new information in the network. The first is an increasing the payoff. Another option is an choosing the key nodes from the network. The key nodes, considering that, let's consider our Instagram network. which is an each user represented as an one node in the network, and edge representation as an following relationship. So visualize, imagine this network is a very large network, and you have a new product has been there, and for that new product you have to what we can say the promote this new product, so that many of the larger users or all of the network can buy this network, buy this product. So for achieving this, what could be the ways now currently is doing means, suppose if you have any product, you are launching any product, what could be how you can promote on Instagram. So there is a one possibility, you are choosing the influencing users who has higher following users, right? Let's consider as an celebrities nodes are there, and there is an also influencing node. Those are not as such celebrity, but they has an higher follower. Many of the users, they are watching their content or they are following their content. So you can approach to them key users, those are influencing users, and there you are convincing to them key users, and then that key users will promote that particular product in the network, so that many users can buy. Also we are, suppose there is a new product has launched, we are also saying, oh, there is, and Shah Rukh Khan is also using that particular product, so we can also buy that, right? So there is an likewise the information can be adopted actually. So this is the another way how you can promote, how you can achieve the complete cascade by uh, for a new information by selecting a key nodes, key people from the network. So this option is also correct. So in this question, the two options are correct. Increase the product payoff, and another option is find out the key people, which can help to buy other people's to new information. Okay, let's move to the next question. Assume a model for collective behavior. Collective behavior means what? Let's see. After reading the question, let's discuss about that. Collective behavior where the threshold for each node is represented near to the node. Which of the following statement are correct? Select all that apply. Okay. So let's first discuss what is a collective behavior first. The collective behavior means what that? Suppose I have three neighboring nodes are there, three friends are there. So if three of them, I mean, suppose uh, three of them has decided some, they are choosing to go. Let's take as an choosing to go a trip actually, trip to Kedarnath. Like, okay, so let's take a real time, real world example so that you can easily understand the concept. Okay, right. So what we have discussed, a node is there, a user is there, and that particular user has an, let's take as an five nodes are there. Particular node has an five, his friends are there, five neighboring users are there. And the out of five, some of the users has decided to go to plan a trip for a Kedarnath, right? So but that particular node has saying that if greater than three peoples, greater than three peoples are going to the participating in this plan, going for the this Kedarnath trip, then I will also go, right? So from the out of five friends, suppose they are going four peoples or three peoples are going to the going to the Kedarnath trip. In that case, that particular node is also participating in that, uh, going to that particular trip, right? So this is an collective behavior. Collective, collectively it is going means collectively decision it is taking, right? And another thing is that means this is one way. It's not directly collective behavior. It's stating that. Another is saying, suppose uh, this is only one node we are saying that, right? He is, if he has saying that three nodes are getting given going to the Kedarnath trip, then I will also go. So there is five friends are there. There is a the five of each has an their own condition. Yeah, the another user has saying only four of the out of four of the neighbors has going to the friends of my friends has going to the Kedarnath, then I will also go. So another users has their another condition. The two of the friends are going to the um, Kedarnath, then I will also go. Right? Likewise. So if all are has satisfied, suppose everyone has saying two two and they are connected to each other. So they said, oh, everyone is going. Means they we can go then because greater than two people are going to participating in that particular plan. So the collective decision they have taken, we will go to the Kedarnath when everyone has satisfied that condition. Greater than two friends has going to the um, Kedarnath. Right, right. So here is also the same condition has given it. The threshold. So this is a threshold. I already said the UV. Let's but using that context, let's assume this. Let's consider this example actually. Okay. So U V W X. The three peoples are there. Three users are there. So U is saying that, including me, including you itself, the three of the my neighboring users are going to the participating in the Kedarnath trip. I will also join that particular trip, right? So but he has only two information, only W and V, right? He doesn't know the X will go to the means X node will go to the will join to the trip or not, right? Likewise, W can say he has also three shoot, but he has only two. He doesn't know about you will also join uh, mm, the trip or not, right? So there is a lack of information here, lack of connections, right? So you can say, let's say, so this is one scenario we have discussed, which is related to the collective behavior decision. So considering this, let's see the options are there. Node U knows the threshold of V. Node U knows the threshold of V, right? And W, right? Node V, because he is directly connected to the V and W. It is incorrect, right? Node V does not know the threshold of W. Node V, yeah, you can see here. Node V does not know about the W because there is a no connection here. Sorry, I drawn. Might be confusing the color. So there is a no connection. So the V does not know the threshold of W. So this is also correct. Each of them easily decide to protest. It's not possible. Protest. Okay. So here, this is means already in lecture has this example has discussed in the context of the protest. Right? If my neighboring nodes, neighboring friends are participating in the protest greater than this threshold, then I will also the participate in that particular protest. Likewise, we have considered, I have taken the example of that Kedarnath trip, right? Likewise. So each of them is, it's not possible because they are not connected to each other. The W has not information of V and U has does not information of X, right? Each node has an incomplete knowledge of the entire network, right? So the option here, the 1, 2, and 3, the each node has lack of information. You can see is incomplete information. U does not has the information of X. X does not have the information of U. W does not have information of U. V, and V does not have information of W. Okay. So the three options are correct here. 1, 2, 3. I hope this has been understood. Means it is an understood. Understood. If you have any doubts, let me know. Yeah, let's jump to the very large question. Might be you will get fear about this. It's very how it is written actually, but it's very simple exam. Okay, I will read a question. Please listen carefully and try to solve yourself. Okay. At the end, I will also try. I will definitely solve this question, but try to solve yourself so that you can easily solve the this current year assignment question easily. Okay. Yeah. So while solving the question, you will get a silly doubts or silly mistakes, so that we can discuss here. That is a benefit for you, right? Okay. Let's move to the another question. Given a network as shown in the following. So this is a network. Okay. Let's analyze only the network. There is a two community. Okay. Means after watching this network, what could be the analysis by your analysis are there? The two communities are there, and there is a weak tie in between the communities. Only one connections are there. So let's see what question says. Assuming that initially every node in this network has adapted behavior B. Along with this means reading this question, we'll also understand this figure as well. So at the initial, they are saying that initial every node has adopted the B information, B behavior. Let's say that, or B. You can consider any context. B product, new product, or B behavior is there. There is, and suppose let's take as an any behavior. Let's take as an aggressive behavior or hate speech behavior. So everyone is uh, taunting on any political person. You are also taunting on particular that person because your friends is also saying bad words on that particular political person, right? Likewise. So the B behavior is there adopted initially in the network. Okay. Then next a new behavior, that is a new information. New behavior A is introduced in the network, and the nodes 7 and 8 are the initial adapter of this behavior. So where is the node 7 and 8? Here. The node 7 and 8. This is an 8 right? 8 has adopted the B A information at initial point of time. Okay. Let's see the another further question. Initial adapter of this behavior A. That is, node 7 and 8 now have adopted behavior A, and the rest of the nodes have adopted the behavior B. Okay, means the rest of the nodes has already means adopted the behavior B. That's an initial state. The payoff associated with A information, A behavior, which is an A3, which is an 3, and payoff associated with the B information, you will get as an B is equal to 2. After the introduction of this introduction of this new behavior A in the network, all the nodes will start weighing their options. Sorry, weighing means they are changing their options, changing their behavior, and might change their behavior. Okay, this leads to a cascade in the network. When the cascade ends, which all are the nodes have who have adopted the behavior A. Have you understood the question? So the question has given a network. In that network, they are saying that all of the node has adopted initially a B behavior. All of the nodes. Out of this, all of the nodes, only two nodes has adopted the new information, new behavior, which is an A behavior. And those nodes are the 7 number node and 8 number node who has adopted the new information. Considering this fact, another they have given the payoff condition, which is an for the A information, you will get a 3 payoff. 3 number is payoff. Higher the number, higher benefit you will get by adopting the information. The lesser the payoff, that is a less benefit you will get by adopting that particular information, new information. So here is saying that if you are adopting the A new information, you will get a 3 points, 3 payoff. If you are adopting the B information, you will get as an two number payoff. Count means that is value payoff. So let's calculate, or let's try yourself. Okay, let's try yourself and let me know what could be the uh, cascade means diffused nodes, influenced nodes. What could be the nodes which has adapted the new information A after the cascade diffusion? Try yourself. Let take a time, and if if it is a wrong answer, let it's fine. Okay. At the end, I will also solve this question. Yes, anyone? Yes, anyone? Okay, no problem. Yeah. So let's solve this question. So the B, let's see the other. Let's see the other nodes. That is in this is in six number node, five number node, right? So the sixth node has an this node. This I will take another color. Okay, this one. The sixth node has an three neighbors. Out of three numbers, three has an adopted A. Sorry, two has adopted. Information has adopted by two out of these three nodes. Three neighbors are there, right? And B information has adopted by only one node. So 2 into 3 and 1 into 2. This is a payoff for A. So the payoff for A is equal to 3, B is equal to B 2. Right. So you will get as an 15, sorry, 6 and is in 2. So greater you will get in payout by adopting the information B. Right. So this node is adopted the new information. See this node. B information. So for this B information, we have to consider the previous. So this is a new information, right? We are not considering directly the this current scenario. This is the next snapshot we are calculating it. Means finding out which users adopted this information. So out of three, two are as an E information updated. This is also getting as an adapted by that new information, because out of three, the same two into three and one into two is, and six is equal to two. So it is considering the B in A information. Let's jump to the this four. Four will be get adapted or not. Okay, the four in four. So 4 has an 4 neighbors, right? Out of 4, A information has adapted only one user and B information adapted by the 3 users. So 1 into 3 and 3 into 2. Which one you will get higher payoff? So that in 3 and in 6. So he is not adapting the new information. New information is not adapted. So the finally adapted information, the further is not, further adaptation is will not be happen right here. So you can see here the how which nodes are adapted. The new information 7, 8. This is an 6 and 5. So these nodes has adopted this new information. This is the option B. 2 is correct here. 7865. Right. I hope you have understood. This is very simple pre-op calculation we have done here. Let's move to the last question. Let V be a node in a graph. In a graph. Okay. V a node in a graph. Suppose a p fraction of the neighbors of V. P fractions are there. The p fractions of node there. Okay, and 1 minus p fractions. You see, those users has an A behavior, and 1 minus p fractions node has an B behavior. B behavior adopted the B behavior. Okay, behavior A has a payoff of A, so this is a payoff A, and B has a payoff of B. So as already stated in the lecture, that suppose, and right, this is the thing, then B is a better choice for V. So if it is, in the lecture we have considered in the lecture, the A is a better choice. In that case, what could be the our fraction will be there. The fraction will be greater than the payoff you will get higher. So the this is an A means, sorry, this is already suppose. So in lecture we have considered, suppose the network has already adopted by the B, adopted by the A here, already adopted by the A information. You can see here. Suppose that P fraction of the neighbors V has a behavior is already adopted by the P neighboring users, right? And see another user, see that is a B is a new choice, better choice, another user, right? Means new information, how new information is coming. So in the network, A is already adopted by the network out of A plus B, right? So this will get the fraction of the value which will be greater than the phi. If this value is greater than the p value is greater than this value, then it will be adopted by the this b, right? Likewise. So option here is 3 is correct actually. Right? You are also, you can calculate as in, that is in what we can do. P into A is less than equal to uh, b into 1 minus p, right? Less than, because this, from this you will getting higher payoff, right? So that's why, or you can write this way also, 1 minus p is greater than equal to p into A. So the opposite of this we have written in, we have seen in the lecture, but this is the opposite uh, here, what we can say, opposite situation actually. So here, by calculating this, we are getting as in b, A divided by A plus b. Okay. Yeah, I hope all the questions you have understood. Along with that, we have discussed the some related concepts as well, which will be helpful for this uh, assignment uh, solution problem actually in this week, in this year actually. Yeah. Is there any doubts till now? Yeah. Okay. Thank you all for joining this session. Yeah. Let's submit for the next week, week 8, to see the discuss the question of this assignment, week 8 assignment, and best of luck for this week 7 assignment. Okay. Yeah. Thank you. You can leave this meeting. Yeah.